Hello everyone. So we would like to go ahead and start with chapter number 29, which is called Statistical Distributions. And what we're going to be taking a look at is the first section, 29A, called Discrete Random Variables. Now, what is a discrete random variable? A discrete random variable represents in number form the possible outcomes which could occur for some experiment. So let's just go ahead and take a look at an example of a particular experiment. And let's say, for example, that you just flip 2 coins. Now, the question that we could then go ahead and ask is, what is the probability of coming up with heads? Now, being that we have 2 coins, and we're talking about coming up with the number of heads that is possible when flipping 2 coins, I'm going to go ahead and describe the heads as our random variable. So what I would say then is let H, and notice that is a capital letter, let H be the number of heads which show based upon flipping 2 coins. So what are the possible values of H? Because remember, a random variable, in this case H, is going to represent in number form the possible outcomes which could occur for flipping 2 coins. So H is the number of heads which show. How many times can we actually get heads for any time for this possible experiment? Well, if we flip the coins and we come out with 2 tails, obviously that means that we have no heads. So I could then go ahead and say that H could be equal to 0, because what this means then is that for both of the coins, tails showed up. Now, what's another possibility? Another possibility is that when we flip the 2 coins, we come out with 1 tail and 1 head. Well, if that's the case, then the number of heads that we have is 1. And then we could also go ahead and say we flip the coins and 2 heads show. Well, if that's the case, then we could actually go ahead and say that H, which is the number of heads which show when flipping 2 coins, the possible number of times that heads will show is either 0, 1, or 2. This then is the random variable H, and it represents in number form the possible number of heads which show for this particular experiment. So let's say, for example, instead of flipping 2 coins, what if you flip 3 coins? If you flip 3 coins, of course, what you should notice as well is that heads, if H is the number of heads which show, can be 0, because that means that all of them were tails. We could have 1, 2, or even 3 heads shown. Okay, so there you go. That's how we can now go ahead and describe this particular event using a random variable, and that random variable is going to describe in number form all the possible outcomes for that experiment. So, one other thing that we need to take a look at as well, now that we have an idea of what a random variable represents, we need to also go ahead and talk about what types of random variables we have. There is going to be something called a discrete random variable, and let's just use RV. Or there could be a continuous random variable, and again, let's use RV for that. And of course, all of you remember from before the difference between discrete and continuous. So we can now go ahead, based upon the type of event that we have, describe whether the random variable is going to be discrete or continuous, and also list all the possible outcomes using a number form to describe what is happening with this particular experiment. So anytime that we have an event that can use a random variable, we can now go ahead and say that we can show we can show the probability distribution of the event based upon values of the random variable. Okay, and so that's what you come up with. So now we can go ahead and take a look, say for example with flipping 2 coins, and let's just go ahead and erase this part here. If we know that we have 2 coins, we basically know that we could have heads here, tails here. Let's just say that it's a rigged coin, so let's just say that this is 1/3 and this is 2/3. And then here's the second coin. Here's heads, tails, heads, tails. This is going to be the heads again 1/3, tails 2/3, heads 1/3, tails 2/3. So what I can now go ahead and do is I can actually show how those probabilities are distributed for this particular random variable. So let's go ahead and take a look at how we want to show that. So what is the probability of actually having the amount of heads being 0? What is the probability of having the number of heads being 0? So what that means then is we're looking for tail and tail. So we know that we have 2/3 times by 2/3, which is going to be equal to 4/9. For the other particular value that we have the probability of heads being equal to 1. So notice the event that I have is tails head, because that would make 1 head show. So that's 2/3 times by 1/3. And then I can go heads, tails here, and that's going to be equal to 1/3 times by 2/3. So what I notice is it's going to be 2 times by 2/3 times by 1/3, and that is going to be equal to 4/9. And then I can say the probability that heads is going to be equal to 2, and what I come out with is this times that, which is going to be equal to 1/3. 1/3 times by 1/3, which is going to be equal to 1/9. So notice that what this random variable is going to be, random variable will allow us to do is actually to look at the event itself and describe all the different possibilities that we could have, because we now can go ahead and express the outcome as a random variable. So of course, one of the things that we can do now is we can take this information here and we can graphically represent it. Okay, so what we have, this is, I'm going to go ahead and move this over a little bit. This is the probability that h is going to be equal to the value of h, which is either 0, 1, or 2. And this is the value of h. So, let's go ahead and use this as a little h there. So, the values that we can have is either 0, 1, or 2. And if I wanted to show what the probability would be, the probability of it being equal to 4/9. And let's say for our sake that this is going to be 1 here. 1. And then the probability of the h being equal to 0 is 4/9, which is about a little bit less than 1/2. So let's just say about there. The probability of h being equal to 1 is also 4/9, so it's about here. And then the probability that you can actually come up with 2 heads is going to be 1/9, which is about there. So we can now go ahead and show graphically as well what the probability distribution will be for this particular event, and it will describe all the different events that are possible.